Welcome in, everyone. In this video, we are going to cover simplifying complex fractions. And a complex fraction is simply a fraction that has a rational in the numerator or denominator or both. So a lot of times you'll see fractions in both, or rationals in both the numerator and denominator. It essentially just looks like a fraction inside of a fraction, okay? And we're going to explore two methods today in solving, or I'm going to show you two methods of simplifying complex fractions. The first one is going to be to make the numerator and denominator each one rational expression. So if we have addition or subtraction happening in our numerator and denominator, we're going to go ahead and combine those and make it one whole rational. And then we are just going to multiply the numerator by the reciprocal of the denominator. So essentially we're dividing by a fraction, and when we divide by a fraction, we get to multiply by the reciprocal. So looking at our first example, we have 5 over x plus 4 all over 1 over x plus 4 plus 2 over x. And so our numerator has just one rational expression, this 5 over x plus 4. Our denominator, though, is adding two rational expressions. So what we're going to do is we're going to use our adding and subtracting rationals to combine this and make it one fraction. In order to do that, we have to get common denominators. So I'm going to multiply the second term by x plus 4 over x plus 4. And I'm going to multiply the first term by x over x. And so what that's going to become is my numerator stays unchanged, x plus 4. We are now going to have in our denominator x times x plus 4, and we need to make sure we distribute out anything if we're multiplying up top. So it would become x and then plus 2x plus 8. Okay, and I just combine our like terms here, so I'm going to simplify this just a little bit more to make it 5 over x plus 4 all over 3x plus 8 over x times x plus 4. So now that I have one single rational term in my numerator and in my denominator, I'm going to move this over. I'm going to go ahead and multiply by the reciprocal. So I have 5 over x plus 4 times x plus 4 over 3x plus 8. And so now, like we've said in the past, when we're multiplying, really it's just one big fraction here. I have a like factor here, a like factor here. So I'm going to have 5x up top and 3x plus 8 on the bottom for our solution. Okay, sometimes we'll be given rational over rational right off the bat. So I can just rewrite this complex fraction to be x squared minus 9 over 5x squared plus 10x times 10x squared plus 2x over 3x minus 9. And so it becomes a multiplying rational, so I'm just going to make this one big fraction and factor what I can up top. I have a difference of squares here, so that's going to become x plus 3 times x minus 3, and 5x times x plus 2. Then we look at the second part. We have a, well, that should be 20x, not 2x, 20x. I have a greatest common factor of 10x, and so we get x plus 2, and then greatest common factor of 3, getting us x minus 3. So looking to simplify, I know I have an x minus 3 here and x minus 3 here. I have a x plus 2, x plus 2. I have a x and an x, as well as this 10 over 5 would just simplify to be 2. So when all is said and done, it's going to simplify to be 2 times x plus 3 over 3. Will be our solution there. Okay, so method 2 is we are essentially going to get have the rational in the numerator and denominator, have common denominators, and then once that happens, it just becomes numerator over numerator. Okay, it's going to kind of start off the same. We still want to have one rational in the numerator as in the denominator. So if we look at our first example here, it's the same as what we had up top. Okay, and I'm going to go ahead and simplify and just skip to this step right here, where we got to one rational, because that's still going to be the same thing we have to do. So I'm going to rewrite what I know this is as what we simplified it to over here, or what we combined it to. So I know this is the same as 5 over x plus 4 all over 3x plus 8 over x times x plus 4. So right now, we look at the denominators for here and here. Rational up top, rational in the bottom. And in order to get them to be common denominators, I'm going to have to multiply this one up here by x over x, because in my denominator I've got x plus 4 times x, and this denominator I just have x plus 4. So I'm going to multiply by x over x. So that's going to leave us with 5x over x times x plus 4 all over 3x plus 8 over x times x plus 4. So now, because I have a common denominator here, as I do here, really I'm just going to take my numerator over my denominator. So it's going to simplify to be that 5x over 3x plus 8. Which is the same answer we got up top here. So let's go ahead and do that same method. We want to get common denominators up top as well as down low. So my first step I'm going to do is I'm going to go ahead and factor what I can for both of these rationals. So I'm going to have x plus 3 times x minus 3 all over 5x times x plus 2, and then 3 times x minus 3 all over 10x squared, or not 10x squared, 10x times x plus 2. So as I look in my denominator up top and my denominator on bottom, really I just have to multiply this expression by 2 over 2. And so when I rewrite this, we have x plus 3 times x minus 3. Oh, gosh darn it. My apologies. I want to multiply this one up top by 2 over 2. So back up. My bad. So we'd have 2 times x plus 3 times x minus 3 over 10x times x plus 2. All over 3 times x minus 3 over 10x times x plus 2. So again, now that I have common denominator here, I can go ahead and take this numerator over this numerator and rewrite it as 2x plus 3 times x minus 3 over 3x minus 3. And then I'm just simplifying what I can. Both of those cancel out to leave us 2x plus 3 over 3, which again is what we had up there. So both of those are methods for simplifying complex fractions. That's all I've got for you today. I'll see you all next time.